Okay, our next speaker is Jo Clark, and Jo's going to talk to us about implications for organic soils.
Thanks for the invitation to talk about peaty soils. Just a quick question for everyone in the audience. How many of you actually work with organic soils? Put your hands up. Okay, that's a good number, so over half, so this is good. They are, of course, the most fun soil to work with for lots of reasons that we'll cover today. So just give you a quick outline of what I'm going to talk about, so my arguments that I'm going to put forward for this debate. So I first wanted to start with a bit of a recap about organic soils and where we can find them in the UK, for those of you who aren't working with organic soils, because quite often I feel they're forgotten a lot. We see initiatives like 4 per mil and we think all soils are the same, but actually they're not. I'm going to consider what 4 per mil means for organic soils, and then thinking about how we might implement it. We're going to consider how carbon accumulates in organic soils, what limits that carbon accumulation, and opportunities we might have to increase carbon accumulation in future. So what are they and where can we find them? So as Bridget noted before, soils aren't equal. They're not all the same. They're actually very, very diverse. And in the UK, we can kind of split them between upland and lowland soils, because basically in the uplands, it's cool and wet. And even on sites with bad drainage and good drainage, we tend to get peaty soils developing. And in the lowlands, we get slightly different soils developing under the same sort of drainage conditions. So if we go back to our soil forming factors, we know these factors all affect the type of soil we get in a location. And for peat, the key factors here are impeded drainage, sellouts, shallow slopes, no earthworms, and that's really, really key to remember, and that becomes relevant for my 4 per mil argument as we go through. It's wet and cold, and it takes about thousands of years to accumulate. So peat, it grows. It's one of those amazing things. It will grow, it will increase in height over time, year after year. The litter will accumulate on top of each other. There are no earthworms present, and that stops this mixing that you will get in sort of more mineral soils. And they can actually reach up to 8 metres deep or more. And when is it a peat? When is it not a peat? So we've got slightly different definitions in England and Scotland, but essentially it's about a thick layer of organic material that has a high organic content. And it's kind of surprising to note that if you sort of look at this classification guidance notes here for Natural England, that as soon as the organic content reaches above 6%, we start calling it an organic-y soil, which is actually quite low if you think about it. But sort of we're thinking above 20% and often up to 100%. So in the England and Wales here, the map, most of our peatlands are in the uplands. Again, that's the link with climate. And most of our peatlands, our blanket peatlands, they're very rain-fed, and their distribution is controlled by climate. Okay, so we need these wet and cold conditions to enable this organic matter to build up and for the peat to grow. What does this mean for 4 per mil? So as Claire gave us a nice introduction beforehand, we're talking about increasing carbon stocks by 0.4% per year. So what does that mean for peat in the UK? So I did some back of the envelope calculations. Because peat is very, very deep, we have quite a high carbon stock. So using these figures from a review paper, sort of on average across the country, we're looking at about 93.4 kilograms of C per metre squared. And if we look at what a 0.4% increase in that stock, what that actually means in terms of grams of carbon per metre squared per year, it varies depending on the depth that you take into consideration. But if we sort of just look at the top 40 centimetres, as specified in the 4 per mil initiative, you're looking at just around 100 grams of C per year. And then if we look at observed rates of carbon accumulation over time, so the top line, so 56 to 72 grams of C per metre squared per year, is based on monitoring data, and that's monitoring fluxes. Okay, and if you use the paleo cores, so you sort of take a peat core, measure the date the bottom, age the bottom with radiocarbon, and then sort of divide the depth by the number of years, you can actually then estimate accumulation rates there. And that ranges from 35 to sort of 209 grams of carbon per year. So you can kind of, so based on the sort of paleo data, that kind of level of accumulation isn't totally unreasonable for peatlands. And as we're saying, we're talking about stocks, but actually peat grows. And so if we think about this in terms of a depth accumulation per year, that's about 1.6 millimetres a year, which again those people that do this sort of work, that's actually not too far off what you can achieve in certain types of peatlands. So how does the carbon accumulate? So we know peatlands have high water table. We've got plants that grow, fix carbon dioxide from the atmosphere, got methane, and then we've got losses of carbon through waters, which are not insignificant. So we've got aquatic fluxes and then erosion in some places. So what limits? So if we go back to sort of thinking about the carbon balance, and I think what happens is I was sort of searching the literature for values to put onto this. We know that carbon accumulates because we have more carbon coming in and less going out. But a lot of the research that we're doing at the moment tends to focus on quantifying these losses, and we actually don't know that much about how much is going in. And in a degraded system, we know we've got a lot going out, but we've also got less coming in. So if you look at some of the types of degradation that peatlands are suffering from, there's erosion, loss of vegetation on the surface triggered by different grazing pressures, climate, acid rain, leaving the surfaces bare and allowing water to erode peat. We've got afforestation and drainage. So this is a photograph from the Flow Country in Scotland, where, a few years ago we thought it was a good idea to drain peat and plant trees on them, but actually that's not such a good idea for peat because that's drying it out and actually removing the water that's actually protecting the carbon. Bridget mentioned the loss of peat in the fens, and this is the sort of Holm Fen pole. I don't know if you've heard about this. A few hundred years, the 1850s or something like that. A landowner planted a pole, and the sort of top of that pole there was actually at the surface of the fen, and over time this pole has become more exposed as the whole fen has shrunk, and that's just because of drainage. That's because drains were dug, the soil was aerated, that water that was protecting the carbon went, and the microbes just went to work on that organic matter and respired that carbon away. And you can actually go and visit that pole today if you want to have your photograph taken. And so we have this agriculture going on in lowland peatlands, and that's a real threat to actually these peat soils in these regions. In the uplands we have grazing pressure as well, and that sort of grazing is associated with some purple moorgrass as well, and sort of a change in vegetation communities. And again, that's affecting the type of plants we have on these systems, the quality of litter, and also the hydrology. Burning is another issue as well, and so we're removing our carbon stocks before they've even had a chance to actually be incorporated into the peat. And we've got acid deposition, so that is actually not, this is the best photo I could think to illustrate acid deposition. There's actually acid in that watering can, and this is a Kat Pachensky, who's in the audience. She's doing a sort of acid manipulation experiment here. But again, we know that acid deposition has affected plant communities, and also what Kat's looking at is how that might affect the biology and decomposition processes going on. And as Bridget alluded to earlier, there are some evidence of impacts of changes in pH over time and how that could affect carbon storage. We know that climate change might be a risk, and again, this is looking at the association between peat and climate. And if we sort of project this through climate scenarios, we can actually see that the area of land suitable for peat shrinks over time, and we can identify the regions where we think they might be most vulnerable to climate change and loss of carbon. So that's all very bleak, but there are opportunities if we look forward for actually increasing carbon accumulation. So if we think about these areas where we've got lots of erosion and degradation, we can actually try and stop that loss by stabilising the surface. So there's a lot of activity that's been going on in the Peak District with the Moors for the Future, where they've actually tried to stabilise these rates. And again, if you can stop the loss, you can actually save up to around 100 grams of seed per metre square per year. And again, that's not quite the 4 per mil increase, but it's in the kind of same ballpark in terms of reversing loss. We can re-wet, and again, that's about raising the water table to protect that carbon. And this is a sort of come from a DEF report of a study across lowland peats. And this clearly shows the benefit of re-wetting, because as the water table goes down, you're actually losing the negative ecosystem carbon balance is going down. So the negative sign, this is actually a carbon sink here, and that's carbon source. So you've actually got much more to gain in terms of increasing carbon by raising the water tables here. Okay, so we need to grow that carbon. We need to stop the loss, but we need to grow the carbon by putting the plants back on. We don't have to get a lot of farmyard manure for peat and worry about how we're going to distribute it and put it on the land. We need to just put the plant community back. But interestingly, we don't actually have a lot of data on productivity or plant accumulation rates. I have my postdoc tried to search the literature to find this out, but there's only a few studies from the 1970s. So actually, we've spent a lot of time measuring these losses, but we don't really know the potential of what we can actually put in. And that also goes for the potential, what can be achieved by better control of grazing and also burning. So if you look at this sort of fence here, this is sort of a grazing exclosure. And you don't have to be a scientist to see there's a lot more vegetation on this side of the fence than there is on that side. And all that vegetation will produce litter, and that's litter going into the soil that will then build up over time. So I think that's a big question and something we need to consider. So for organic soils, I've got 4 per mil, but I'd argue because of the depth factor, maybe it's just 4 mil we should be looking at. And the priorities really need to be about stopping the loss and growing the carbon.